Vinod Balakrishna, Head of the Robotics and Automation Department at PSG College of Technology. Has also been serving with IEEE in the capacity of IEEE RAS chairperson at the Madras section. He is a renowned academician with over 21 years of experience and has also had 8 years of rich industrial experience. He has completed his postgraduate degree from PSG Institute and has also completed his PhD from the Bharatiya University, Coimbatore, on CNC machine control. In addition to being an academician, he is also being a principal investigator for various funded research projects like MAV navigation, pattern recognition, and mobile robot for waste handling, and has carried out 11 funded research projects for various prestigious institutes and organizations like Indira Gandhi Center for Atomic Research, NIOT, HAPP, AR&DB, to mention some. Dear Sir, on behalf of IEEE RAS Kerala chapter and all the attendees of today's session, I welcome you to this evening and also wish you the very best for your session titled Robotics Post-COVID-19.
Thank you, Abdul. Thank you for the nice introduction.
Next, I extend my greetings to the respected members of the RAS Execom and my fellow student team members. And lastly, and most importantly, I extend my dearest welcome to all our energetic volunteers and the wonderful participants who are attending today's session. So once again, I welcome you all and would like to invite our honorable speaker, Mr. Dr. Vinod Balakrishnan, for a session. Welcome you, sir.
Thank you, Mr. Abdul. Just a minute. Let's share the screen. I hope all of you can see the screen, the slide.
Yes, sir. Yes.
Okay. So thanks a lot. I should thank Dr. Jisha, Chair IEEE RAS Kerala chapter, for inviting me for this Robotics and Automation Leaders Symposium, an online webinar series. So I understand from her that at least one program is conducted in every month. So people from industry, academia, and research are invited to share their experience, knowledge, and give some suggestions, as well as find out opportunities with youngsters, especially students and faculty members, on how effectively this RAS chapter can deliver solutions to the society. So I congratulate IEEE RAS Kerala chapter for organizing such wonderful programs. So there are other programs as well, like storytelling by experience sharing by entrepreneurs. So very interesting programs. Very happy to see a lot of things are happening in IEEE RAS Kerala chapter. I'm heading the Madras chapter, so we also have webinars. We also invite people from industry, academia, and research to come and share their experience, sometimes some hackathons, sometimes some networking sessions, some opportunities for internships, especially now it's all online, so some online internships and some training programs. So these things are happening here too. Hope all of you and your family members are safe and healthy. I know it's a session before your dinner, so I will make sure that it will end, or it will not cross more than 45 minutes of presentation, and maybe a few questions at the end of the session will be fine. So you can see in this picture, there's a robot here. It's an industrial robot. If you can read it, it says the logo says it's PSG. So I represent the organization PSG. It's the PSG and Sons Charities. It's almost, it started in 1925. That was when the trust was started. And there are around 23 institutions under this trust, including 2 industries. So we make machine tools, we make foundry castings, and we do have medical hospitals, medical college, arts college, 2 engineering colleges. So I represent the oldest engineering college. In fact, oldest in the sense in the state of Tamil Nadu. There are 5 autonomous aided institutions in those days. So PSG College of Technology is one among that. Sorry, 3 out of the 3, one is PSG Tech. So this college started in 1951. So I'll just give, I'll tell you how to take this presentation forward. So I'll give you some introduction about the institution, the programs we have. Then a glance of industrial robots and medical robots. Why medical robots has been chosen? You know that we are passing through a very, very tough time in the history. So what robots can do, especially in the field of medicine or healthcare. And we will summarize with a brainstorming session on what we can do together. And if you have some questions, I'll be able to. I'll be happy to answer that. So this program of BE Robotics was started in 2011. In fact, I think we were the second institution in the country to offer an undergraduate program. Then we later started an international program also. It is called as BE Mechatronics Engineering, where the students, they study 3 years in PSG and 1 year in Germany. And another program where students study 2 years in PSG and 2 years in Australia. So that is the international program, and the BE Robotics and Automation is certified by the Anna University, Tamil Nadu. So far, I have to add this year, so passing out will be around 400 students, graduates have come out of this program, and campus placement is normally around 86 to 90%. That is the normal placement. A lot of our students find scope for higher education, especially abroad. These numbers I have to update. I think it is about 100 plus right now. So major places where they go are US, Germany, Australia, and Japan. Interestingly, we have around 30 entrepreneurs from this program so far. There are a lot of startups. Students have won several prizes, awards. We have MOUs with around 21 industries. We have 11 centers of excellence with various industries in the campus, in the department especially. We have with Siemens, Fanuc, Eden, Omron, Adept, Danfoss, Festo, ePlan, Beckhoff. Then there is another center with Department of Heavy Industries on welding automation. So these are the various centers of excellence in the department. And right now around 250 plus students. So that is about the department, and our faculty strength, totally 15 faculty members, 9 are doctorates, 5 pursuing their PhD. And the department, apart from the undergraduate program, it's a research recognized department. So there are 19 PhD scholars. They work in various fields like design, manufacturing and industrial engineering, sensors, machine vision, then controllers and soft computing, machines, drives and controls, automation of welding systems, and AMRs, and healthcare robotics. So these are the major areas where the research concentration is. 6 of the faculty members are drawn from industry. 14 years is the average experience of the teaching faculty members. We have so far, like in the last 10 years, 18 sponsored projects have been carried out for various organizations, and it totals to a tune of 37.5 crore. And we do have 6 project engineers in the department. We do have around 250 publications and organize some workshops and conferences. So that's about the department and my background. Apart from that, the academics, we do have academics and research. I showed you the PhDs as well as the funded projects. Apart from that, in our department, we do have a product development group where we focus on developing products for some of the issues what we face in day-to-day life. So I'll show you some of the pictures of that at the end. Okay. So coming to the robotics, as you all know, I know you are all connected to robotics in some way. So, and also you have been attending several webinars, expert lectures by various industry as well as academia experts. So generally it is classified into industrial robots and service robots. These are the two major family of robots. And industrial robots, as you all know, it has gone through a series of refinement. It has come to a saturation in terms of its architecture. The more and more developments are happening in terms of its intelligence. So making these industrial robots more and more intelligent, autonomous. Also, there are a lot of situations where it demands to work along with humans. So the human-robot interaction of industrial robots. So that is one big field. And another is service robots. Service robots, that's a big basket, contains medical robots, UAVs, means drones like flying things, underwater robotics, unmanned surface robotics like both land as well as sea, then medical robots. Medical robots itself is a big basket. Defense robots, rescue robots, firefighting robots, entertainment robots, teacher robots. So the patient assistance robots, cleaning robots, UV disinfectant robots, and taking care of welders. And who knows, in another 10, 15 years, there are robots that can be your life partners, who knows. So that is the trend at which the service robot industry is growing. Okay. And coming to the market, so this is what you can get from the internet, like how the market has been growing. You can see the pre-COVID and post-COVID, hoping that COVID will end by 21 at least, or 22. So there will be a jump expected. So in 2019, about 48.7 billion US dollars worth, that was the expectation. But I think it was very close. It was 46 or 47 billion US dollar was the market. Then it is predicted that by 2025 we will have 75.6 billion. That is going to be the expected market, considering the need for robots in the post-COVID scenario. As you all know that in a shop floor, people work. So there are too many people. If there are future chances of similar pandemic or corona kind of epidemics that may transfer through air or some medium, then it will be very unhealthy for people to work with so many people around. Some industries are now thinking of reducing the number of manpower, making the process more and more automated. So more and more robots for various applications. So that, considering that effect, I think these numbers are going to still go up. So there is a huge demand for industrial robots in the post-COVID scenario, hoping that COVID will end. Let us pray for that. But the life is going to be totally different. So far, we have been seeing a life which was different, and this pandemic has taught us how to have a totally different kind of new normal. So wherever people group, like whether it is an office, whether it is an institution, whether it is a factory, marketplace, wherever robots can do a big role, better role, I think slowly we will see a lot of people being removed from several conventional jobs. So that will post us another big question, then how to reskill the people who may lose their jobs, what else they can find as jobs. But as you see, when more and more robots comes to the market, we need more and more robotic engineers, more and more engineers to take care of these robots, service them, maintain them, sell them, spares, supply of spares, resale them. So there's a huge market. Supportive market is also going to evolve along with the industrial robots. And over this past, you may be knowing Unimate robots, the first kind of robots used for a manufacturing shop floor, where these robots were supposed to handle picture tubes for TV manufacturing. From there, the robotic industry has come through a big change, especially in terms of industrial robots. But this 50 years of change, almost 50 or 60 years of change, has brought in a kind of saturation in terms of its structure, in terms of its kinematics and dynamics, in terms of its whether it's a serial or a parallel kind of combination. So the major configurations you can see here: Cartesian, SCARA, articulated, cylindrical, delta. Delta is a serial robot. Then polar robots and collaborative robots or cobots. This is the new generation robot which are made to work along with humans. So other robots, if you have seen any of the industry or industrial videos, you would have noticed that these robots will be kept inside maybe a cage or isolated from humans, because when humans goes close to these robots, chances that it may hit or humans may get hurt. So that leads to big issues. So, but these collaborative robots can work along with humans. So it is like two friends walking. So you can talk to the robot, you can communicate, and the robot also will see that you are not hit or hurt during the process of any manufacturing or inspection or whatever the process happening in the industry. Yeah, so according to the structure, there are two specific ones. One is the power is transferred serially. So there are joints J1, 2, 5 or 6 or 7. Then we have parallel kinematics, where instead of serial power transmission, it's parallelly transmitted. And if you see the industrial robot market, what kind of robots we get it in India, mostly it is, I would say 90-95% of the robots that are being consumed by the Indian industries. 2019, 3,000, close to 3,900 robots were sold in India. So 90% of those robots were imported robots, maybe from Yaskawa, KUKA, Hyundai, ABB, Kawasaki, Universal, Fanuc, Panasonic, Nachi. So there are several brands, but these are you can see most of the brands, the most popular brands that are sold in India. And on the right hand side, you can see another bunch of names which you may not have heard, but slowly coming up. Paris is one of the, all these companies are Indian companies. So Paris was one of the pioneers in India who started making robots in India, system integrating robots. Then there is MCA Robotics Chennai, Systematics Bangalore, High-Tech Robotics, then Tata started making robots, then Shastra from Kerala, then De facto, Precol, 𝐕𝐢𝐧𝐶, and PSG, we have also started making industrial robots. And apart from that, there are other names, I think, from Kerala, Asimov, Gen Robotics, Inca Robotics. So more, I think, concentrating on the service robotics. So this, the Kerala soil, I think, is more fertile for the industry robotics because it includes the hardware as well as the software, which I think we'll be able to do it better than any other process that happens in an industry. So we would like to see a lot of robots that are, or robotic companies emerging from Kerala, which, and as we were told, there are several new colleges coming up with robotics and automation programs. The manpower or the skill required for development and manufacturing of these robots will be there available in Kerala. And I think that is very, very important. And I should congratulate Dr. Jisha for framing a great curriculum for the Kerala Technical University, which will be adopted, I think, throughout most of the colleges in Kerala. So the foundation is already laid, companies are coming up, and a lot of scope. So at least after this webinar, please think about how, in what way you can contribute, and think about starting a company in robotics. You can sell it to every part of the world. I'm not just joking, because I have two samples in front of you. I have two students who came out with startup companies who started products. One company has sold 20 UV disinfectant robots to Singapore recently. Another company sold 5 AMRs to a US company recently. So it is not that since you are from India, we are from a small town, we can't sell it to other countries. People are watching you from throughout the world. You just come out with a beautiful product, then sky is your limit. So you have talent, you have expertise, then nobody can stop you. And now all governments are supporting. There are enough funds for startups. So I think the government of Kerala is also doing a good thing by supporting startups. So, and robotics is another big area where a lot of good things can be done. Conventionally, the industrial robots are used for some of these applications, like material handling, because transfer, pick and place, palletizing. We are currently doing a project for one of the FMCG companies who has a big warehouse in Bangalore. So for loading, unloading cartons and gunny bags from a conveyor to the truck, so far they have been using manpower. So manually they pick these cartons and load it inside the truck. But as you know that this pandemic has forced these companies to, because when you go inside the truck, most of these trucks are fully covered trucks. So it will be tough for people more than 2 or 3 to go inside the truck, because chances of spreading COVID are very, very high. So that has to be avoided. So the thought of how to avoid this, so a robotic solution has emerged. So AMR with a robot on top of that will be able to transfer materials or cartons and gunny bags from conveyors to the fully closed trucks. So because it is the conventional concept of where industrial robots are now being changed. Another operation was in process operations like welding, because conventionally very, very tough to get people for welding. It's a highly skilled area. Spray painting, spray coating, cutting, grinding. A lot of process operations are already automated, and it's very popular in automobile manufacturing industries. All automobile manufacturing companies are, the process operations are automated. So a lot of robots are employed in all these applications. I know I know the cheapest cars in India so far were than Tata Nano cars. In fact, even that or those cars were made of 139 robots in their process stations. And the autonomous cars or the like e-vehicles of Elon Musk, like Tesla cars. I was fortunate enough to have a visit to the Tesla factory once. So 2 years back, they were having 2,880 industrial robots on one shop floor. So nearly 3,000 robots making cars in a factory. Imagine the size of the factory, 3,000 robots. The Tesla factory in California or San Francisco is as big as 9 football fields. So many robots, and more and more robots are being added. So these are conventional process where robots are heavily employed. Then assembly and inspection. And if you see on the right side, there is the robot density wise top 10 countries. Japan tops the list with 295, so you can see the list. And if you just closely observe, these countries are actually forced to go for robotization or automation because they have a very high shortage of manpower. Japan, Singapore, South Korea, Germany, Sweden, Italy, Finland. So all these countries are facing negative population growth, which demands more and more automation and more robots for various applications. China, even though the country is very populated, we couldn't see here in terms of density wise, but China is now the world's biggest consumer of robots. So 2019, when India consumed nearly 3,000 robots or 3,800 robots for various industrial applications, the same in China was 140,000. 140,000 industrial robots, only industrial robots. So there is a huge difference between two big crowded countries. The density of, because China is a big country and the population is also nearly 143 crore, whereas India is about 139 crore, I think, right now, so 33 crores. So, but still, the number of robots consumed by China are very, very high. So now we are forced to a stage where industries have to reduce the number of people, not just because of maintaining the quality or just for the sake of improving the production, but also for the safety of its own workers or its own people. So that is what pre-pandemic, it was more of applications in highly developed countries with declining population like Japan, Germany. Or the purpose of robotics was there to reduce the cost, and human workers were very expensive or are still very expensive. So it was cheaper to go for robots. And post-pandemic, the priorities or the priority has shifted to the workers' safety. This is not just to improve the productivity or reduce the cost, but safety of the available people on the shop floor. So the number of people on the shop floor has to be reduced, more and more robots, so that whoever left on the shop floor will be safe to work. So can we use robotics to break existing barriers to human creativity? So this is one thought process that will go in the industrial robotics sector. Coming to the service robot sector, you can see there is a graph here where the blue ones are the industrial robots, gray bars shows service robotics, and green the total ones. So from 2016 to 2020, if you see, though there is a steady growth in industrial robotics, service robotics is expanding or selling much more, because that's a big segment. The basket contains a lot of areas, but the interesting thing is by 2020, service robotics has almost leveled the industrial robot market, and it is going to outgrow further And by 2025, it is expected to be $102.5 billion is going to be the worth of this service robotics field. If you can kindly recollect for the industrial robots, I think it was somewhere around 74, 75 billion US dollars. So this service robotics is going to totally see a different picture. And with COVID kind of restrictions, I think more and more this number is again going to increase. And one major component of this service robotics is the healthcare robotics. So you can list some of the pictures are shown here. I think you can find out what are the applications. The first one is a surgical robot. I'm sure a lot of hospitals in Kerala, they are using robotic surgery. Robotic surgery doesn't mean that robots are doing the complete surgery, but it's a robot assisted surgery. So if you Google it, you can find 𝐷𝐴 robots, one of the monopoly in medical robots or surgical robots. Several hospitals in Cochin, I know that they're using surgical robots. So the advantage is that this assists the surgeon. It's a non-invasive surgery. So patients will come back to life much more faster than a conventional surgery. The surgical time will be very less. So on a particular day, the doctors or the team of doctors can do maybe twice the surgery than when they do conventional form of surgery. And everything is recorded. So something goes wrong, no chance of going wrong because it's all tutored, it's all recorded, trained. So, but even if something goes wrong, everything is recorded. You can go back to the history and find out what went wrong. Or if you want to have a relook at the surgery after 1 year, the entire files may be available. And possibilities that doctors from experts from other places or any part of the world can join. They can, through internet, they'll be able to visualize, or even telesurgery is possible these days. So a surgeon sitting in New York will be able to do a surgery in Trivandrum or Kottayam or Tiruvalla or something like that. So that kind of medical robotic technology has developed. And these are very precise because it is all with camera, 3D camera. So surgeons may not trespass to unwanted areas where the knife will touch or the laser beam will touch. So it is much more safer for the patient, so that he will be, he can be sure that he is safe. So the robotic surgery is safe, faster, recorded, history is there, and it doesn't require so many doctors. So maybe a senior surgeon who will be sitting on a master console and 1 or 2 people to assist. So a smaller team is enough. But the doctor needs to be trained. The doctor has to be trained on how to use a surgical robot. And for that, we need trainer robots. So we have made a project, we have done a project called as Endo Trainer. So we have developed a surgical robot. I will show you the picture of that. And as you know, this is, I know some of our friends or relatives have been affected by COVID this time. The hospitals are full. No bystanders are allowed inside. You don't know what is happening to your friend or relative. If we have robotic assistants, you can see in the second picture here. So he can, through this robot, you can talk to the patient, or you can see actually what is happening. You can also find out his needs. So a robotic assistant, very, very required for the present condition. Then there is a UV disinfectant robot. Then a medical dispensing robot. And this robot on the extreme left bottom, this is a robot made in Coimbatore by one of the first batch students of our program. The The company name is Catamaran Robotics. So they have deployed this kind of robots in some of the hospitals. So as you know, in an ICU or in a ward where a lot of corona patients are there, and now a lot of doctors and healthcare workers are affected by COVID. So a lot of people are on medical leave. They may not be able to come. So there is a scarcity of health workers or experts on the wards. So a nurse to run between various places, it's tiring for them. So there are robotic nurses that can bring materials. They can check some of the parameters of the patients. They can report to the doctor. They can transfer some materials to the required place. So such robots are of great demand. So that is another application. And this is a picture which have been taken in PSG hospitals. So this robot has been deployed there. So the kind of medical robots, okay, I missed showing you the global medical robotics market. So it is expected to grow with a very high rate and about 16.742 million US dollars. That is going to be the market. Okay, coming to that various segments, surgical robots for laparoscopy, orthopedic, neurosurgical, steerable robotic catheters, and for operating all these kind of robots, surgical robots, the doctors needs to be trained. So Endo Trainer is another robot that can be bought by all hospitals for training the surgeons. Rehabilitation robots, therapeutic, assistive exoskeletons. If you have some weakness in standing up and walking, there are exoskeletons to help you and walk, to lift weights, robot nurses, diagnostic chatbots, disinfection and pharmacy. So there are a lot of applications. You can also even think in your present day situation, what kind of robots would you like to have? So these are all solutions that will emerge and will be sold in big numbers. Okay, this we discussed why we need such robots. This is the surgical robot, 𝐷aVinci's picture that is showing the surgeon sitting on the master console. So he has some joystick kind of controls with his two hands. So when he makes his controls here, the slave, this is called as a slave unit where the patient is there. So the slave units can be operated from the master console. So here the surgeon can see through a camera. We can zoom to any level. So the camera is already inside the patient, and he'll be able to do the surgery in a very precise way. And this is the pictures of our robot. This is a medical endo trainer what we have made. And there you can see the doctor here. He is Dr. Ramalingam, a senior urologist and a laparoscopic surgeon of Coimbatore. So he has, in fact, the whole idea came from him, and it was made with funding support from Department of Science and Technology, Global Innovation and Technology Alliance, KITA, with Korea Advanced Institute of Science and Technology, 𝐶AST, as our academic partner, and L&T Technologies as our industry partner. So this has come, this was the first prototype. We made the second one. The trials are almost over. The product is ready to be launched by L&T. Then there are rehabilitation robots. I think in the post-COVID situation, because there are a lot of complications expected because of COVID. So surviving is one thing, but surviving after the COVID, healthy is another thing. So people have problems with muscles, bones. So we may need a lot of physiotherapy treatment. Again, that is another field where we have scarcity of human capital. So robots for that. Okay, I showed you this picture already. So robots, nurses that can deliver materials, and from like pharmacy, from the places they kept bedsheets, linen, etc. Medicine. then diagnostic chatbots. You would have seen a lot of advertisements in newspapers and online, like YouTubes and all. Now, we are very scared to visit hospitals, not just because of for we having COVID, but if something else, if you want to get treated for something else, still we fear to go to a hospital because chances of getting infection through COVID can happen. So what we do is we can call a doctor and the doctor on call. So I think this will change. It's going to be more of you'll be able to a chatbot will be able to get a lot of information from you, and based on some of your data, if you can upload, that will be able to predict what or tell you that what is your real or possible reasons of illness and what kind of treatments or medicine you have to take, and whether further investigations are required or not. Yeah, disinfection is very, very important, especially when you have a lot of manpower scarcity, especially on the cleaning side, cleaning of the shop floor, the things the COVID patients handle. So I'm not sure about the medical guarantee of whether UV disinfection can 100% disinfect, but still to an extent UV disinfection is proved to be successful. So autonomous UV disinfectant robots are also getting popular. Again, there is a company here in Coimbatore from our own robotics group. They have started making this kind of robots. And then pharmacy delivery robots, testing robots for manufacturing of tablets, robots are employed. And now the swab collection, that's another big thing. So robots are employed for swab collection of COVID patients. And if you can recognize this picture, this robot from the picture, it is a universal robot, which is a cobot. So this can work along with humans very close. Then ultrasound scanning robots. Again, a cobot arm, a manipulator you can see along with the ultrasound scanning machine. So a lot of transformation is going to happen in healthcare, and more of intelligent robotic systems, and we need artificial intelligence for that. One is for keeping us healthy, to maintain our own healthy condition. Then for early detection of diseases. I'm sure you would have heard about genetics, genomics. So if your family members, their history, if all this data are fed to an AI-based system, and if your DNA is already there in the the systems will be able to tell us that what kind of diseases are awaiting for you. Maybe at the age of 40, you may tend to get a cancer, or at 45, something else, at 50, diabetic, at 60, high blood pressure. So all these things can be detected or predicted early based on your ancestors. So genetic AI-based healthcare systems are coming up, which can give a lot of indications about what kind of diseases you are going to get and what we can do for that. We can do a lot of precautions. So knowing earlier is better. So it will not lead to a very critical end. So you will have a better quality life when you can detect things early. And diagnosis. I think doctors will be supported with a lot of diagnostic tools. So that will reduce the doctor's time, because the doctors have to, you would have observed some of the outpatient booths of government hospitals or even some famous private hospitals. There will be a lot of people waiting in the queue. So it can be a chatbot which can do the first kind of filtering and direct to which doctor they should go first. So a lot of diagnosis tools will be coming up, and robots will be able to navigate. There are robots now to take patients and guide them to which direction they should go. There are robots that can be on the reception, where they can when a patient comes, it can find out the temperature, find out from the eyes, from the pupils, something on their health, and record their data and pass it on to the concerned section. And doctors, the decision making of doctors, sometimes they may be confused on what kind of a disease is this. So they may have to consult with senior doctors or maybe expertise from outside the country. When you have a pool of data available, the doctor's job will be much more easier. And for treatment and for end of life care, because that's another very difficult period, taking care of elders. In our countries, it's not a big issue so far, but as when you have more and more elderly people and less children at home, taking care of them is a big challenge. So continuous monitoring of people, their health, and the data will be transferred over maybe from wireless, from there to internet, and it will be going through doctors or to the relatives. So remote monitoring, and subsequently the corrective actions can be taken. And research and training. So a lot of things in healthcare are going to be robotized, and a lot of intelligence is going to happen in several fields. In terms of the products, there are a lot of medical equipments, hardware, consumables, which are more focused on historic and evidence-based care. These are the conventional medical products what we have been practiced so far. So based on the reports that the machines gives us, the doctors comes to a conclusion. Then there are a lot of medical platforms now, wearable. There are a lot of wearable rings, chains, then pendants, which can just wear it. So it just collect, or watches that collects the information and sends to your laptop or mobile, or so you, on the go you can monitor your health conditions. So differentiation by providing service to key stakeholders focused on real-time outcome-based care. So that makes things much more easier. And the intelligent solutions for evidence or outcome-based health coming through AI or augmented reality. And this mainly focuses on the preventive care of people. I think that is how the trend is going to be. So if you see the broad spectrum of where robotics comes into picture here in patient care, human-assisted supervised robotics, especially in the post-COVID scenario, these are required. It is under various sets like substitutive robotics. Some areas where robots can substitute humans. Some of the applications of healthcare, sanitation, cleaning robots, logistics, material loading, unloading, disaster management, drones just going and collecting information, drones in floods, drones in other natural disasters are helping a lot. So instead of people going and collecting and supervising things, robots can do a better job safely. And collaborative robots, robots working with humans for industry, as well as for various applications, even in terms of software applications. Then supplementary robotics, education and research, especially when education is becoming online. I think that is going to be the, at least for a few years, or online or hybrid mode. So how to educate or train students using robotic tools. So there are robots where you can program and access or control through remote, like internet. Then data mining, management and curation, recording or controlling clinical procedures and surgeries. Another big area is humanoids. Though it's not that matured, but to my knowledge, because when we are doing some kind of literature survey, there are 260 or 65 companies worldwide doing a lot of research on humanoids. So maybe if you remember the movie iRobots, they say by 2050 you may have a lot of humanoids than humans. We don't know all these things will become true, because we thought humans population will be multiplying and a lot of people will come. But I think post-COVID, what is going to happen, we are not sure. And who knows, more and more of machines will be there to support this planet. So, and then there are other social and ethical issues will come when you have more humanoids, and how to network and coexist between humans and robots. So these are all post-pandemic possibilities of robotics. Yeah, robots possesses strength, precision, and speed, and humans, we have ingenuity, judgment, and dexterity. So if we can just combine, so we see really a scenario where a lot of robots are going to come in various areas, not just performing something or assisting something. In fact, for entertaining us, for even making artwork, or construction of houses, doors, 3D printing, a lot of robotic applications are coming. So we are, in fact, working on a metal additive 3D printing machine. The process is automated. The inside, the layer by layer deposition of metal is done using a robot. Because earlier days, if you see the rapid prototyping machines, it was all like a CNC machine concept of controlled access. But now the robotic control systems have much more accuracy than this controlled access machines. It will be more flexible. So the what machine we are currently working is on a robotic metal additive manufacturing machine. Okay, this is what I told you in the beginning, that like some of the products what we have developed. So we have one 10 kilogram payload industrial robot, which has been made and testing is in progress. Then another one is 2 kg payload, which can be used for small pick and place applications as well as for training. So this is also ready. And this is a product which we have developed recently for the COVID. So we used to keep this in our main entrance, where when people come, it detects the temperature. Then it asks some information, whether you have fever, whether you're feeling something, and it collects your, first time it collects your data, and next day when you come, it recollects by detecting your face. It will be able to identify and greet you that you are this particular person. You will again check for your body temperature and then direct accordingly. Then we have some mobile Bluetooth based platforms for basically for students to learn. And there is a 5+1 or 5 degrees of freedom 3D printed robot arm, which we have started selling to training institutions and colleges. This is much more enough to learn the kinematics and dynamics of programming a robot. You don't have to go for an expensive industrial robot of like 15 or 20 lakhs. And there's a simple one for school children, clock it. They can just, these are all simple stepper motor based ones. And there is another one with an educational robot. You can make this robot to dance. So, but it's all drag and drop kind of programming. And this is the indoor trainer, that the second version of it, which we have developed. And we have also done 2 drones. This drone is with a payload of 300 grams, which can capture images while it flies. And we are in the process of making a 5 kilogram payload drone for pesticide spraying. So these are some of the products what we have developed and will be commercialized. It will be coming to the market. Okay, that's a short glimpse of what are the activities or what possible we can do in robotics. And I request all of you to think. These are some of the applications which are all people are currently thinking about. But apart from that, there will be a lot of unique applications where you can find out from your locality, from your neighborhood, maybe your own house, and try to find solutions for that. And when you have a research question, when you have a question ready, the problem is there, the solution arrives. Only thing you need to do is do a brainstorming, network with friends, find out like-minded people who are experts. Now, as you know, it's lot of communities globally, so you don't have to limit yourself to your locality. You can have a friend from Russia, from Japan, or from US who will be able to assist you and help you, or even sometimes even get you some of the components. So abundant opportunities, all kind of possibilities exist. I think it is our passion and our, it's only the quest, the curiosity to do things. And if you have any questions, I'll be happy to answer. Thank you.
That was indeed a noteworthy session from Dr. Vinod. He has touched upon all fields pertaining to his topic, robotics post-COVID-19. Thank you, sir. Now it's time that we get on to the Q&A session. I welcome Engineer Radhira Krishnan, Treasurer cum Joint Secretary, IEEE RAS Kerala Chapter, to take over the session. Ma'am, please.
I think Adira is having some technical issue, so I will manage. Any questions? I think no one has posted questions in the chat box. So participants can unmute and ask.
Probably they're having dinner.
No, this is a regular timing. I think
Okay.
this is the right time. Generally, people are free after the class timing and
Okay.
yeah.
Hi, good evening, sir. It's nice
Good
to have
evening.
you here. Sir, I would like to know, are there like really much a great impact for, the collaborative robots in our country as of now? And I would like to know, can we foresee collaborative robots within our society, like as a common factor, especially within our southern regions, because in Mumbai, Bangalore, and all, it's really much developed compared to Kerala, and I think Tamil Nadu too. I don't know much about it, but in Tamil Nadu and Kerala, I would like to have your suggestion of forcing that, would that really be part of our lives, in within the next 5 years or so.
You mean in the service or the personal side or in the industrial side?
In the service side, sir.
Service side, okay. Service robotics in India, I think, except like medical field, people are still hesitant to use, except some of the houses will have now this iRobot for floor cleaning, correct? I don't know how many of you have an iRobot at home. So now
Yes,
there are shops in Bangalore where you can just walk in and buy one iRobot for home cleaning. You can also get it through Amazon or any delivery agents. So slowly it is coming. I know there are a lot of houses in Coimbatore where we have cleaning robots. There is another company which we, in fact, I have not shown you that product, which we have done a project, solar panel cleaning robots, where humans work with robots, because initially we need to lift, somebody has to go there, lift it and keep it on a track. Then the robot travels through the surface of the solar panels and cleans it. So there are applications, and sewage cleaning, yes, there are robots. So slowly the landscape is changing. I am sure in 5 to 10 years, a lot of robots will be able to see in Kerala. It is going to come. Industrial robots is already there. You can see there are a lot of robots like universal robots. They're already, in fact, all brands. All brands of industrial robot manufacturers right now, they have collaborative robots. So in the service industry, it is coming up. If I wish no one in our group or no one attending this should go to a hospital for a surgery, but if you have to, or someone have to go for a surgery, will you prefer a robotic surgery or a manual surgery, a robot assisted?
Sir, we definitely take in considerations of the experience of doctors and also the human error, the possible human errors. So I would be comfortable if it's a mixture of both. And I think there are currently going on. So I think in 2017 or 18, the first robotic surgery was there. Like long distance surgery that the doctor was a doctor was in some other place of controlling, and the robot was in the actual surgical room for the surgery.
Okay. No, but the question is, if assuming you want to do a surgery, will you go to a robotic surgery?
If my doctor definitely say that it is really good, and definitely yes, because the confidence of the doctor is really important in the technology too, and
Yes.
that will definitely convince the patients to take the robotic surgery.
Yeah. So that is what, like, the patients or the users also needs to be well informed about the advantages of going for robotic surgery. So that is why normally people, they don't prefer. I know there are 2-3 hospitals in Coimbatore, they have robots for surgery, or robotic surgery is being done. And we are in regular touch, but sometimes they say people are hesitant to go for robotic surgery because they say robots, no, it can go wrong. No, in fact, it is much more accurate than, I'm not blaming any doctors here, maybe some of our relatives or parents may be doctors, I'm not blaming them, but human error in anything is possible. And assuming a doctor doing 5 or 6 surgeries per day, his concentration levels, his energy levels will like reduce as he goes on, and chances that sometimes mistakes do happen. But robots, that problem will not be there. Robots can do any 24/7, it can work. So, and the tiredness of the doctors will not affect, because he is guided, he knows like what is the problem, what is that he has to do, and everything is shown very clearly. He is able to watch what is happening, is being recorded. So the surgical, the accuracy of this kind of robotic surgery is very, very high than going for completely on a manual surgery. Probably, I think people, another thing is maybe the cost. So cost-wise, once it comes to the same levels, I think with well-informed users, robotic surgery is going to be much more in demand, and it is steadily increasing. There are 100 plus surgical robots in India right now, in spite of the cost of these robots. Do you anyone know the cost of a surgical robot, a 𝐷aVinci, of the minimum, maybe one for endoscopy? Approximate how much it may cost?
Sir, I have read it in a paper, like an article. A robot that was introduced in Harvard, approximately it was an Indian article. I think Indian Times. It said around 75 80 lakhs, they say.
Okay, but you 𝐷aVinci robots, I think you can get a quotation. It will cost you around easily 10 crore plus. And when you add more and more features, the price goes up. So that is one thing which may be discouraging for some of the hospitals, because the initial cost is high. But those who have employed or deployed these robots, like example Apollo hospitals, most of their the branches, whether it is Delhi, Mumbai, Chennai, every place they have the robotic surgery now for various applications, because they know like how economical or how the return of investments can be easily possible when you have a trained team of doctors who can easily do more number of surgeries than a conventional way of doing surgery. So not just medical robotics, I think we will be seeing a lot of service robotics in the future in Kerala. And you said like in North maybe you have a lot of service robots applications. In South, no, it's not like that. In fact, South is much more technologically evolved. If you just leave 2-3 pockets like Pune, Mumbai, or Delhi, apart from that, I think we are much more ahead on in terms of this robotic technology.
Sir, as you have told that like 10 crore plus is a huge amount, and are there efforts done to reduce the cost in the medical industry or the other industries as of now, especially by students who does the final year project or who are in their graduation phase?
Of course, there are possibilities of coming out with low-cost robotic solutions. Recently, I'm not sure whether you heard about the technology innovation hubs proposed by the Department of Science and Technology, Government of India. So all over India, 25, mostly IITs and IIScs were given an amount of around 135 crores plus to start a lot of research activities in robotic and AI-based areas. And IIT Delhi is spearheading the robotics activities. There is a consortium of researchers and industry. They are trying to come out with low-cost surgical robots because I am also being a part of that. So the target is that around 40 to 50 lakhs or even closer to 1 crore. That should be the highest margin. So below that, India should be able to come out with a surgical robot. So that may be possible. Like the major problem where you see in all kinds of these industrial robots or medical robots or CNC machines is that, can you anyone tell why this cost is so high? What is lacking in our country?
The education, sir, the skilled people is really
No, I
difficult.
think we have skilled people. We have very educated people. In fact, most of them, they go abroad. If you see the heads of a lot of multinational companies of these big robotic companies, a lot of Indians, a lot of Mallus working there. It's not the kind of talent shortage, something else.
Sir, is it because the demand is very low? Like when demand goes up, everything, the production price of anything comes down.
Yeah,
Is it,
you are true. You are absolutely right. Why demand is not there?
sir? Because most of it is because of stereotypes, I guess. Because many people still think we doctors or uh, any other types of service robots. It's basically just like you said. Many people have trust issues with it, and like many of them are still not able to accept the facts that robots are being able to do things better than humans. So that might be one thing, and another reason might be because the immediate demand. Like for example, uh, if a new robot comes into market today, its price is obviously going to be a little high. So
I think
once
that was
people,
the same question from your friend. Why the prices are so high? How
yeah,
to reduce the price?
so like the initial investment, sir. So that's what I was telling. Like the initial investment, nobody is ready to make it considering the risk factors. Uh,
So when someone says that the budget or the quotation is 10 crore plus, only the big
initial
hospitals,
investment,
yeah,
initial
only the
investment,
big
nobody is
hospitals
ready
will
to
be
make.
ready to buy. That's true.
Yeah.
But in the
Initial
same
investment,
robot,
nobody is ready
almost
to
the
make.
same features of that robot, if it is
But they don't.
available for 1
They
crore, will they buy? Or
maybe, sir.
50
That
lakhs?
depends on the hospital.
Yeah, they will buy because the hospital is also going to make money. Maybe a hospital who is still conventionally doing the surgery, doing only 5 surgeries per day. If you have a robotic surgery
Can
and
do 10 surgeries or
yeah,
maybe
10 or
more.
15 surgeries per day, naturally they will buy it. So the cost. So why the cost is so high? Because some of the key technology elements in these products, whether it is a robot, whether it is a CNC machine or a 3D printing machine or a medical like a scanning machine, there are some key elements like controllers, drives, and actuators, or even including sensors. So all the major key elements of mechatronic systems we import. We depend on China, we depend on Korea, we depend on Germany, we depend on US or some other country, Japan. So these kind of components are not made in India. Why? Why can't we make servo motors? Do you know any company that makes servo motors in India? There are one or two companies, but apart from that, on a large scale, like a leading manufacturers like Siemens or Fanuc or GE, control technique, something like that on a global scale. Is there any company in India? No, no one. Why? Is it that we don't have educated people? We have. But some of the core components that may go inside this technology are not available in India. Maybe if you're talking about servo motors requires high power magnets, which again we have to depend on China or some other country. So there are various components, leave alone all those things. When you talk about a controller development, we Indians are good in writing algorithms. But when it comes to making a PCB, like a multi-layered PCB with chips, we don't have any big chip manufacturers. We don't have any good facility for PCB manufacturing. We don't have big drive manufacturers. So there is a big vacuum of area where we have to grow further. But the government has taken a lot of initiatives recently. They have invested a lot of money on electronic projects. Companies who are willing to come up and start some products in those segments. A lot of funds have been given. Maybe some of you also can think about starting some kind of products like that, which will go as an product into making robots and machines.
Sir?
Sir.
Yep.
Yes. Yes.
Okay, thank you. I just want to, first of all, I just want to say it's a pleasure for asking you a question. I have two questions. First of all, I'm studying in an electrical engineering branch. I'm certainly interested in robotics, but the major problem is that what kind of projects should I start with and all? Like, what is the actual schema of starting getting into this field? If you just want to do robots and all, like for example, if you just want to make a drone, you should study about the aeronautical part, the physics part and all, plus mechanical parts, how the mechanical parts actually work. So there are a lot of stuff that is actually focused on this kind of stuff. So how should we actually start doing this thing? And the second part is that, I'm currently pursuing electrical engineering. So I'm definitely not going to have a professional degree in robotics engineering. So is that going to affect what I'm just doing?
Okay, that's a good question. A lot of students may have the same question. In fact, when we started, I showed you some of the products from our product development group. So it took almost 2 years for a team of 5 or 6 engineers to make some of these products. So when we started doing these things, we were also totally blank, maybe some theoretical knowledge. But apart from that, where to start, how to make a drone or maybe an endo trainer or a surgical robot. But once you start doing things, when you start analyzing, so first do level is literature survey. When you start reading and formulate the question and which segment you want to address. So there is another course. Maybe if you are irrespective of the branch, I think most of these colleges will offer a course on product design and development. So there is a textbook by Steven Epinker. So if you can find it out, it is available in the internet, and there are also online courses on product design and development. So once you start identifying which problem you are going to address, so find out the question, the research question, what is that you are going to try to solve. Then you have to conceptualize, okay, this is what I am going to do. Then next thing, how you are going to do, what are the things you have to do that. Basically, you need to have design, a lot of mechanical systems you have to design, but everything needs a lot of calculations, as you said. How much of force, how much of torque, what kind of speed, what kind of rapid rate, traverse rates, a lot of calculations you need to do. And for that, physical movements, you need to have actuators. So what kind of motors can give that kind of torque? So, but these things you don't have to do because these things are already there. You have to just drag and drop. So you can have a lot of manufacturers' data. So you can collect that and you can, in fact, now making things you can sit at home and make a drone because a lot of things are available. I'm not telling you about a kit, buying a kit and assembling. It's not like that. You can even design your own things and start doing. So fundamentally, you need to have thorough basics of engineering, whether it is electrical or mechanical or robotics. Fundamentals should be thorough. And once you are clear about your how to calculate the force, how to find out the torque, what kind of drive system should be required, then you start building up. Of course, it goes through several stages of iterations. I told you about the 𝐷𝐴𝐵 robots. It will look like a very technologically interesting, marvelous stuff. But that company took 20 years and a lot of billions of dollars to make that product to this stage. Several prototypes, several rounds of refinements. It takes time. No one can make a product in a day. So you have to think only about that, like Elon Musk. That should be your passion. And of course, one person cannot be able to do everything. Maybe you're good in electrical engineering. You concentrate on the electrical side of that. You can think about the sizing of motors, sourcing of sensors, how to integrate this, how to write the control algorithms, what kind of driver softwares are required. So you can focus on areas where you are good. You can have one or two friends. One may be good in CAD designs. So some may be doing in Creo, or some may be doing in. And if you are trying to make a industrial robot, there are a lot of simulation softwares are right now available. So you can use those tools and design your things. But the thing is that you have to start moving. You don't have to start with a big project initially. Start with smaller ones. Make things work. Then you will get the confidence. And of course, asking anyone is don't feel shy about that. Don't think about others watching you. Just enjoy the journey. I think you will succeed.
Hi, sir.
I think Muhammad, I think as we are running short of time, shall I ask some questions from the chat box?
Sure, ma'am, please.
Yes. Sir, even though it's a general question, Nabil is asking how to find internships in robotic companies and what are the prerequisites that we need.
Nabeen is in which semester?
Nabil?
Okay, there are. I don't know whether it is possible for you to go in the 8th semester a complete 6 months internship, because it is possible in our system. So the final semester is only for internship. So every student is supposed to, it is compulsory, unless he has back purpose. He has to go for an internship, an industry internship or university internship. So in my department, we have tie-up with around 10 foreign universities. Some universities in US like CMU, Purdue, Michigan State, NYU, and I think some more. I'm not able to get it. So there are 5-6 universities in US and a consortium of 7 universities in Germany, 2 universities, University of Deakin, University of Southern Australia in Australia. So all these places our students can go for internship. So there is a department level interaction between faculty members of those universities. The advantage when you go for an international internship is that in 6 months you will become a totally different person. You will understand the culture, the way their system works, the way their students learn. So total refinement will happen in your life, and that opens up a new segment of like avenues, like doing masters abroad. So that sparks interest in you to do, and you will be able to identify which is the best university in AI or which is the best universities in underwater robotics. Or so you can specialize in the area you want because you will be closer to those universities. So one is university internship. Our students are also allowed to go to IITs. So normally IIT Delhi and IIT Mumbai as well as IIT Chennai, we do have student internships. Apart from that, industries. So most of the students who go for university internships will be planning for master's program immediately. So that is why they prefer university internship, because once you work under a professor, chances of that professor converting or offering him a master's seat is possible. So those things happen. And if you are planning for placement or conversion of internship into a job, then it is better to identify and go for industry internships. And in the 6th semester vacation, also we are asking students to, or we find, in fact, in this batch we have about 72 students. So 40 of them have already got internship for the summer. It is only 6 weeks internship. Though this COVID time, it is more of online, but still we ask them to go for internship, because the way you think, try to solve the problems are very, very different from what we do on a textbook-based learning. They post you problems. The next day, maybe morning you will have a review. In the evening, you have to make another presentation. So they make you think and work. So please find opportunities for internship. Now the question is where to find. There are thousands of industries in India who are willing to offer internship. Only thing is we need to connect. That is the importance of talking to each other, finding. You just, how many of you have ever started writing an email with a statement of purpose and a resume? All of you have got a statement of purpose. When you apply for an internship, you should have a SOP, a beautiful resume which tells you about what you have done in the last 2 or 3 years. It should have some mini projects, some papers you have published or conferences you have attended, some webinars you have attended. So that makes it more interesting, and the companies or the people who can give you internship will be interested in your CV. So make your resume look better, nice, and once they go through your statement of purpose, they should feel that this guy is very excited, he has very good potential, let me try this guy for something. If you have seen people who end up in companies like Google or Tesla, or they have all done something different, right? If you want to go for MS in Stanford University, how to do that? Whether CGP of 9.5 is enough? No, that is not just enough. You need to have a lot of activities. So in the 4 years of your undergraduate program is a place for you to accumulate things, knowledge, and make your CV looks beautiful.
Yes, sir. I think I will add to one more point. Try to participate in RAS events, IEEE events. So recently we had an event this month itself, May, Roadway to Robotics, for which we had around 400 participants.
Wow.
So we have conducted a quiz along with that, and the winners are given internship opportunities.
Oh, great.
So like that, try to, in addition to what Sarah has said, I would request you to attend the sessions and events by RAS chapters. Be part of IEEE RAS chapter.
Yes, IEEE RAS can connect you to industries. In fact, industry people may not have the time and energy to come to academic institutions and pick students for internship. So it is our responsibility to knock their doors. And what we teachers, I am sure Dr. Jisha also is also doing the same. Like what we can do is invite people from the industry and present them before you. So that is an opportunity for you to talk to them, get their contacts, get some commitments from them that, okay, we are going to take 5 internships this year from your college. So that is how it works. So the more talks you attend, it is not just attending physical attendance, but emotionally, spiritually, you be lively, ask questions, get their contacts, invite them, and I think that will be the way to go forward.
Sir, I think already it's 8:26. Can we take one more question?
Yeah, no problem.
Okay, so here is a question from Akshay. Sir, could you please suggest 2 or 3 international communities in robotics for supporting in discussions and funding, etc.?
Are you in LinkedIn? Because there are a lot of groups in LinkedIn also, like professional groups. They post problems They take you to the company websites. Their problems are listed there. So there are a lot of things, a lot of groups. You can just Google and find out. But if you want some professional groups, I think LinkedIn has specialization wise. We have vision systems, image processing, sensors, robot. There are a lot of groups.
Yes, thank you so much, sir, for elaborate answers for all the questions. So that's all from Q&A. Over to Adarsh.
Before we move on to the conclusion of the event, I request all of you to just switch on your camera so that we can have a click to keep it as a beautiful memoir.
Okay, thank you. Hope I will also get a copy of that.
Sure, sir. Abdul, can you stop sharing the screen? Jose is taken, right?
Done, ma'am.
People are leaving when you start to switch on the camera. Don't bother about
It's
that.
taken, Abdul?
Yes, ma'am. I took the photographs.
Okay, okay. Thank you.
Okay, thank you, Abdul.
Thank you, sir.
So a word from my side. I really enjoyed the session. A lot of questions. Thanks a lot, Dr. Jisha, for giving me this opportunity. I am very happy that a lot of activities are happening in IEEE Kerala chapter, RAS chapter. So keep me informed. I'll be happy to share maybe in our RAS chapters about what is happening in Kerala chapter. In fact, in
Maybe
the
you should also share, yeah, so you should
sure.
also share the details, sir, like
Sure,
the
sure.
events each year. Thank you
Okay.
so much. Yeah.
Thank you.
Adarsh?
Now, let me invite Mr. 𝐁𝐴, Technical Coordinator, to propose the vote of thanks.
Am I audible?
Yes, Jose. Yes.
Okay, thank you. The distinguished resource person of the day, Dr. Vinod Balakrishna, sir, very respected guests, professional EXICOM members, RAS SB leads, my dear friends, and the very active participants over here. A warm good evening to all. Let me thank Dr. Vinod Balakrishna, our keynote speaker, for spending his precious time giving us such a valuable session in simple words. I believe that all the attendees might have found the session engaging with your way of presentation that indulges the participants to attend the session with a lot of curiosity. Your lecture has gained us a lot of knowledge, which gives deep insights into the different robots that are saving our lives in the medical field, even during this COVID situation. On behalf of the IEEE RAS Kerala chapter and all the participants, I express our heartfelt gratitude for presenting such a beautiful session. Thank you, sir. We hope to have you again at another wonderful session in the future. As a token of our gratitude, we would like to present you with a virtual memento. Sir, please.
Oh, thank you. It's my pleasure.
Thank you, sir.
I'm so happy and honored. And a lot of people attended. I'm in fact nearly 100. So at this evening
Actually,
time,
we
it's
were
really
having one more screen running with
It's
more than
around
70 people.
98, 98 on the
Oh,
second
great,
screen.
great. Yeah.
great.
Thank you, sir. Next, let me extend a note of thanks to all our guests from the professional community for gracing the event with your esteemed presence. Thank you all. Now, I would like to thank the professional EXICOM members of the IEEE RAS Kerala chapter for making this event happen. Lastly, but very dearly, I thank all the student volunteers and the participants who have worked and joined to achieve this successful completion of the event. Thank you everyone for joining us.
Thank you.
With that comes the wrapping of the event. We wish all to find yourselves safe and healthy.
Thank you. Same to you. Okay, so I'll sign off.
Thank you.
Thank you. Bye.
Yeah, thank you so much, sir. It was very nice. So many people interacted very well. Thank you so much.